This is the ending of our complex numbers. That was 10.7, and your quiz on 10.7 is going to be at the on Thursday. Okay, so 10.7 and what we do today, your quiz will be on Thursday, and your test is a week from today. Okay, and then your final exam is about 2 weeks from today. So things are winding down. Okay, multiplying complex numbers. To multiply two complex numbers of the form a plus bi, we multiply as though they were binomials, which means we either distribute or we use the FOIL property. This is at the end of what we did on Thursday. Okay? Then we use this relationship right here. I squared equals -1. So we know that I equals the square root of -1, but I squared simplifies to -1. And so that's going to be important in this process, okay? So let's go ahead and do some of these. So here I have 8i times 7i. Now these are pure imaginary. There's no real part of this these numbers, and so I just have 8i times 7i. So I'm going to multiply 8 times 7, and 8 times 7 is 56, and then I times I is I squared. What do we know about I squared? It's -1. So what I have then is 56 times -1. And 56 times -1 is -56. Okay?
Is that the one from
Thursday.
Okay.
It's the one from Thursday. Okay? Okay. So now with this one, I have a monomial times a binomial. So I am going to distribute this. I'm going to distribute it. So I have 5i times 4. Then I have minus 5i times 7i. 5i times 4 is going to be 20i. Minus 5i times 7i. 5 times 5 is 35. And we've got our negative right there because that's part of the problem. And then I times I is I squared. Okay? This we're going to leave as just I. We're going to leave that as 20i. But this I squared can become -1. So I have 20i minus 35 times -1. What's -35 times -1? Good, positive 35. Okay? Now, a plus bi is standard form for a complex number. So what's going to come first, the 20i or the 35? Good, so it's going to be 35 plus 20i. And that is my final answer right there.
So the only time that we'll simplify is when it says to simplify?
When you've got I squared, that's when you're going to simplify anytime you have I squared. If you have an I, you don't want to change it. But if you've got an I squared, you do. Okay, good question. Sorry, guys. Okay, now we're going to FOIL. Okay, we're going to FOIL because I have a binomial times a binomial. So we're going to treat this the same way we would any other binomial times a binomial. So I've got 6 times 7. What's 6 times 7? Good. Then I've got 6 times positive 4i. And that's going to be 24i. Okay? There's no I with this 6 right here, so it's not I squared. It's just 24i. Then I've got -3i times 7. That's going to be -21i. then I have negative 3i times positive 4i. So that is going to be negative 12i squared, because negative 3 times positive 4 is negative 12, and I times I is I squared. So a lot of times students will combine those like terms, and then they'll stop. But I have one more thing I can do. What can I do? The I squared is negative 1. So that's 42 plus 3i minus 12 times negative 1. Okay. Negative 12 times negative 1 becomes positive 12. And then I'm left with 54 plus 3i. And that is my final answer. So when we're multiplying, I squared equals negative 1 becomes important. Okay? Now we're going to do some division. It's going to look like a rational. And this is the end of lesson 10.7. We're at the very end of this from last Thursday. Can I go to the next screen? Okay. So now what we're going to do is we are going to simplify this division. We're simplifying this division. So the first thing that I want to address right here is this square root of negative 64. So I'm just going to leave my 16. Okay. Now, when I take the square root of negative 1, what is the square root of negative 1? I. Okay, so then I'm going to have plus I, and that's going to leave 64 inside the square root. Can I take the square root of 64? What is it? 8. So this is going to be 16 plus 8i over 8. Don't get quick. A lot of times students just want to cancel these two right here. But you've got to factor before you can simplify. So I'm going to write factor out GCF first. Okay? Your GCF here is 8. So then I'm left with 2 plus I. Now, because I factored out the 8, now I can cancel that. So my final answer to this is 2 plus I. Okay? Okay, can I go to the next screen? Okay, now I want to focus on simplifying this right here first. I want to focus on that. So I'm going to do that part off to the side. I have the square root of negative 27. The square root of negative 27. We know I can come out. And then I'm left with the square root of 27. There is a perfect square factor in there. What's my perfect square factor in 27? 9. And so then I'm left with 9 times 3. What's the square root of 9? So I have 3i on the square root of 3. So that is just this right here. So now I'm going to rewrite this as 3 plus 3i on the square root of 3 over 6. Okay, a lot of students want to just cancel that 3 and 6, but we must factor first. What factors out of it? Good. So then I'm going to have 1 plus I on the square root of 3. I just factored the 3 out, and that's over 6. 3 goes into 3 one time, 3 goes into 6 two. So my final answer here is 1 plus I on the square root of 3 over 2. And that is the end of lesson 10.7. The end of lesson 10.7. So now we are starting today's lesson, which is on solving quadratics. And that's from the notes I gave out today. Okay? Is it okay if I go off this page? Okay, so now we're going to look at 11.1 and 11.2, and this is it. Can you believe it? Then we have review and etc. Okay. So we are solving quadratics. Now, a quadratic is in the form ax squared plus bx plus c. Okay? So a quadratic is something raised to the second power, and we solve those by setting them equal to 0. And the way that we have learned to solve them this semester is we have factored them. But sometimes they can't be factored. So sometimes we need another way to solve them. And we're going to talk about a couple of different ways to solve them today. The first way that we're going to talk about is using the square root property. Now I want you to think about the number 16. The number 16. Now if I took the square root of 16, my answer is just 4. Whenever we see that square root symbol, it means that we are only talking about that positive value. That's the value when we see the square root of 16. We're talking about that positive value. However, what if I have x squared equals 16? That is different than saying the square root of 16. So that is different. Now here, x squared equals 16, there are actually 2 values that x could be. One of them is 4. Does anybody know what the other value is? Good. It is positive and negative 4. So anytime we've got a squared or x squared or y squared and it's equal to a number, when we take the square root of that, we have to include the positive and the negative. Okay, and that is our square root property. That's our square root property. So when I take the square root of that, I've got to account for the positive and the negative. So let's do some of these. Okay. First one that we're going to look at is x squared equals 49. So if x squared equals 49, then x is going to equal the positive and the negative value of the square root of 49. Okay, so what is the square root of 49? 7. So x can be positive or negative 7. And so you could write that as x equals 7 or x equals negative 7. So you actually have 2 solutions here. 2 solutions. Okay. Now, for this next one, I've got to isolate this first. I'm going to go ahead and isolate the x squared first. So I want to go ahead and divide both sides by 2. So then I'm left with x squared equals 2. I'm going to take the square root of that, but when I do, I have to put my plus or minus there. I have to put my plus or minus right there. Can the square root of 2 be simplified any further? No. So x can be the square root of 2, or x can be negative square root of 2. Now remember, this is still a real number because the negative's on the outside. It's when the negative goes on the inside that there's an issue with it being a real number. Then it's an imaginary number. So the negative on the outside is okay. Okay? Now we're going to have binomials squared. We're going to have binomials squared. And this is something that's used when we complete the square. You'll complete the square a little bit in Math 112 with circles and vertex form. But here, we can take the square root here and still solve these with completing the square. Now, a lot of times students see this right here, and they'll FOIL this and set it equal to 0. That's what happens a lot, and that's a perfectly fine way to do it. Because this is squared, you can take the square root of both sides, and then you're left with y minus 3 equals plus or minus the square root of 4. Okay? So all I did was I took the square root of both sides. Okay? And I'm allowed to do that because this is a binomial squared. That's why I'm allowed to do that. So now I can simplify this further. Okay? What is the square root of 4? So this is y minus 3 equals plus or minus the square root, actually just 2. Okay, now remember, this is how many solutions? 2. So what this means is y minus 3 can equal positive 2, or y minus 3 can equal negative 2. Okay? So for this one, I add 3 to both sides, and I get y equals 5. For this one, I add 3 to both sides, and I get y equals 1. Okay? We're allowed to do this because this right here is a perfect square. That's why we're allowed to do that. Okay? Now for the next one, we're going to do it the same way. I'm going to take the square root, okay, and I'm left with x plus 2, and that's going to be plus or minus the square root of 25. What is the square root of 25? Good. So I've got x plus 2 equals 5, and it's plus or minus 5. I cannot get this right today. There we go. X plus 2 equals plus or minus 5. And how many solutions is this right here? 2. So that means x plus 2 can equal positive 5, or x plus 2 can equal negative 5. Okay? So I'm going to subtract 2 from both sides here, and I get x equals 3. I subtract 2 from both sides here, and I get x equals negative 7. Okay. Now, this next one is a little bit more complex. Is it okay if I move off this? Okay, this next one is a little bit more complex because it's not a perfect square. So I'm going to go ahead and I'm going to take the square root of both of these, and I'm going to have 3x minus 17 equals plus or minus the square root of 28. Now I'm going to go ahead and simplify this. Okay, I'm going to go ahead and simplify this. What is a perfect square factor in 28? Good. So then I have plus or minus the square root of 4 times 7 So I have 3x minus 17 equals plus or minus 2 on the square root of 7. And this right here is how many solutions? 2 solutions. So what this means is 3x minus 17 equals positive 2 on the square root of 7, or 3x minus 17 equals negative 2 on the square root of 7. I'm not done yet. I need to add 17 to both sides. So I have 3x equals 17 on the square root of 7. Nope. Sorry, guys. 17 plus 2 on the square root of 7. And then what do I need to do? Divide by 3. And so I've got x equals 17 plus 2 on the square root of 7 over 3. That's one of my 2 answers. Right there. It's one of my 2 answers. Now I need to do the same thing to the other side. I'm going to add 17 to both sides. And I'm left with 3x equals 17 minus 2 on the square root of 7. And then I'm going to divide by 3. So here, x equals 17 minus 2 on the square root of 7 over 3. Okay, so we're kind of taking everything we've learned in this unit and put it into solving quadratics. Okay. Now, I want to go back to right here. Okay, I want to go back to right here. It is not unusual at this point right here to leave it as written together, okay? We're not going to be able to combine any like terms, so many students right here will add 17 to both sides and keep the plus or minus. So then we have 3x equals 17 plus or minus 2 on the square root of 7, and then I divide by 3. So then I have x equals 17 plus or minus 2 on the square root of 7 over 3. It means exactly the same thing. Here, I've got my plus or minus together, so it means I still have 2 solutions. Down here, I've got a plus and I've got a minus. Okay, so what you need to understand is this right here means 2 solutions. Now, when we start doing the quadratic formula, you're going to see this a lot more when we're doing the quadratic formula. Okay. And even if you don't remember how to use the quadratic formula, most people remember the term from high school, the quadratic formula. Okay? And here's the quadratic formula. It will be given to you. You do not have to have it memorized. Okay? And here's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. Here is standard form of an equation, of a quadratic right here. So it has to be in this form. Before you identify your A, B, and C, your quadratic must be in this form. Okay, just like before we can factor it, we have to have it set equal to 0. Before we can use the quadratic formula, it must be set equal to 0. Okay. Okay. So, oftentimes you'll see me write what we plug in red. you'll see me just write it in red. The A, B, and the C is what we're going to plug in. And what's in black is part of the quadratic formula. So we're going to solve several of these using the quadratic formula. Okay? Okay, is it okay if I go to the next one? Next screen? Okay, here we go. So we are going to solve this using the quadratic formula. This cannot be factored. We use the quadratic formula. You can use the quadratic formula for everything, but we specifically have to use it when it can't be factored. Okay, we use when we can't factor. That's when we use the quadratic formula, is when we can't factor. Okay? Is this in the form of ax squared plus bx plus c? Yes, it is. And it's set equal to 0. So I am going to identify my a value is going to be what's in front of the variable squared. My b value is going to be in front of what's the variable that's not squared. And my c value is the constant at the end. Okay? Now, I've got negative b plus or minus the square root of b squared minus 4ac. And everything in red, I've got to plug in based on this right here. So everything in red, I'm going to plug in. The purple part is the part of the formula. So I'm going to have negative. What's my b value here?
1.
Good. And then I have plus or minus the square root. B squared is 1 squared. Minus 4. My a value is 3. What's my c value? Good. Okay, and all of this is over 2 times 1. 3. I'm sorry, 2 times 3. B, negative b plus or minus b squared. Yeah. Okay? Now, you've got to simplify this first. You've got to simplify this first. So focus on what's inside the square root first. So I've got negative 1 plus or minus the square root. This is 1 squared minus 4 times 3 times negative 3. Okay, so you have got to do this computation right here before you can do anything else. So what is negative 4 times positive 3 times negative 3? Positive 36. So then I have 1 plus 36. So students tend to get caught up and make a mistake right here because you try to do too many things at once. Focus on this minus 4ac first. Then deal with your b squared. Okay? Now I'm going to rewrite this again. Negative 1 plus or minus the square root of 37 over 6. Now it's very important that you realize this means 2 solutions. This is 2 solutions. Okay? It's 2 solutions. It means negative 1 plus the square root of 37 over 6, and it means negative 1 minus the square root of 37 over 6. Okay? It means 2 solutions. So you want to be aware of that. 2 solutions. Okay. We ready to do the next one? Okay, this one is not in standard form. So what I need to do is I need to move this 1 to the left. So I've got to subtract this from both sides. If I don't subtract that from both sides, I will not have the correct A, B, and C identified. Okay, so I've got 11n squared minus 9n minus 1 equals 0. I must set equal to 0 first. Must set equal to 0 first. Okay. Now I can identify my A value, my B value, and my C value. Students often make mistakes when my B value is negative. Okay? Students often make mistakes when my B value is negative. So let's see. I've got negative B plus or minus the square root of B squared minus 4AC over 2A. So I've got to plug in my A, B, and my C. So I'm going to have a negative 9, because my B value is negative. What's negative 9? Positive. Okay, then I've got plus or minus the square root. And I am squaring negative 9. You have to be careful there how you put that in your calculator. A negative value squared is what? Positive. So that negative 9 squared is going to be positive 81. Okay? Then I've got minus 4. My A value is 11. My C value is negative 1. Okay? And all of this is over 2 times A. Okay? Now, we're going to deal with what's inside the square root first, and then inside the square root, we're going to deal with this right here. Okay? So I have negative 4 times 11 times negative 1. What is that?
44.
What is it?
Positive 44.
Positive 44. Good. So negative 9 is 9 plus or minus the square root. What's negative 9 squared? 81. And then we've got positive 44. And all of that's going to be over 22. Okay? And so now I'm going to go right up here. What is 81 plus 44? What is it? 125. So then I have 9 plus or minus the square root of 125 all over 22. There's a perfect square factor in there. What's the perfect square factor? Good. So I have 25 times 5. And I have 9 plus or minus 5 on the square root of 5 over 22. And that is my final answer, but I want you to be aware this represents 2 solutions. It represents 9 plus 5 on the square root of 5 over 22 and 9 minus 5 on the square root of 5 over 22. I'm going to write that right here. So this represents 9 plus 5 on the square root of 5 over 22 and 9 minus 5 on the square root of 5 over 22. That's 2 different solutions. Okay, I'm going to let you do the next one. After I get you started. I'm going to tell you how to do something first. Okay, can I move to the next one? Okay. What I want you to do here before you get started is I want you to multiply everything by its LCD. And what's my LCD between 8 and 2? 8. Okay, so I'm multiplying everything times 8 over 1. So I have 8 over 1 times 1 over 8, x squared. 8 over 1 times 1 over 1 times x minus 8 over 1 times 5 over 2. And then I've got 8 over 1 times 0, but that just gives me 0. Okay? So then I'm left with x squared plus 8x, okay, minus 20 equals 0. So I want you to do the quadratic formula with that right there. X squared plus 8x minus 20. Okay. This one could be factored. Okay? You could have factored this one. But I want to show you how to do it with the quadratic formula, because you can solve every one of these by the quadratic formula, whether they can be factored or not. Okay? Okay. So let's see what happens right here. I always want to start here and focus on this right here. Okay? So I'm going to end up with negative 8 plus or minus the square root. 8 squared is 64. What is negative 4 times 1 times negative 20? Positive 80. Okay? Then here, I end up with 2 in the denominator. 64 plus 80 is what? 144. And what do we know about 144? It's a perfect square. What is the square root of 144? 12. So this right here becomes negative 8 plus or minus 12 over 2. Okay? Now, that is 2 different solutions, and we can keep going. And a lot of times students will stop at one of these 2 steps right here. So you need to keep going. What this means is negative 8 plus 12 over 2 and negative 8 minus 12 over 2. Negative 8 plus 12 is positive 4 divided by 2 is going to be 2. Okay? Negative 8 minus 12 is negative 20 divided by 2 is negative 10. So if you can keep going, you need to keep going. Okay? Keep going if you can. So your final answer to that is 2, negative 2. 2, negative 2. Now, we did not talk about the discriminant, but I want you to get a visual of what we're looking at right here. Okay? I want you to get a visual of what we're doing. So what I have right here is I've got a quadratic, and what we're looking for is where does this quadratic cross the x-axis? That's what I'm looking for. And in Math 112, you're going to spend a lot of time talking about this in Math 112. You're going to be looking at parabolas deeper in Math 112, and you're going to be looking at where these functions cross the x-axis. Okay, so we've done a lot with these 2 types of quadratics in this particular course. We have only briefly touched on this type of quadratic. What do you notice about this one on the far right? What does the graph not do? Good. This does not intersect the x-axis. Okay? So we would have this type of problem right here, and our answer would be no real solutions. What do we know about no real solutions? What do we know? When we say no real solutions, what does that actually mean? It means no real solutions, but what could I have? Imaginary or complex. So when I have no real solutions, it means that my solutions fall into that other category of imaginary complex numbers. And so before we do our quiz today, I want us to do a problem and see what that would look like. I want us to see what this right here would look like. We can't factor it, but we can use the quadratic formula to solve it. Okay? So let's do this problem right here. Can I move off this? You guys good? Okay, so we're going to do one more quadratic. So I've got 5x squared minus 5x plus 6. Okay, and we're going to do our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what's my a value for this one right here? Positive 5. What's my b value? Good. And my c value. Good. Okay. So I'm going to have negative 5, because my b value is negative 5, plus or minus the square root. My b value has got to be squared. So that negative 5 is going to be squared. And when I square a negative number, what do I get? Good. Minus 4 times a times c, which is 5 and 6. And all of this is going to be over 2 times a. Okay, we're going to focus right here. That's where we get started. Negative 5 is 5. Okay, we know that negative 5 squared is 25. Now I've got my minus 4 times 5 times 6. Negative 4 times 5 times 6. What does that give me? Good. Now, subtract this right here for me. Okay, so I end up with a negative value inside square root. And once we have a negative inside a square root, we are no longer talking about what? We're no longer talking about real numbers. Okay? And that's what happens right here. We get a negative inside the square root, and so our quadratic does not have a real solution. It has a complex solution. Okay, so it's no real solution, but we can identify what its complex solution is. So what do I do with this negative square root right here, or negative inside the square root? I pull out a 9. So I have 5 plus or minus I on the square root of 95 over 10. Can I cancel that right there? Can I cancel this 5 and this 10? I cannot. I would have to factor out a GCF, and there is nothing that I can factor out. This 95 does not simplify. Okay? 95 is 19 and 5, so I can't take out anything. This is my final answer. Now, there are 2 here. It's 5 plus I on the square root of 95 over 10, and 5 minus I on the square root of 95 over 10. But that 5 and 10 cannot cancel. It's the same thing as if I had 5 minus x over 10. Could I cancel that 5 and 10 here?
No, it's the same thing.
Yeah, it's the same thing. I can't. I can rewrite it as 2 fractions, but I can't just cancel it.